Hello SL2. This topic of scatter plots and line of best fit, we have not seen many questions on the IB exam with it, but it is part of the curriculum, and because the test is changing, we wanted to make sure we reviewed this topic from Algebra 2. And so scatter plots and line of best fit, remember if you saw this type of a graph, a scatter plot graph, you can easily tell what kind of functions that this data would represent. And this one on the left here, that would represent a quadratic function. And the one on the right here would represent a linear function. We can use our knowledge of just quadratics and linear to get an estimate using transformations and our knowledge of lines here. If we didn't have the exact data, we could think about what would the y-intercept here be and what would the slope, looking at our units. But in particular, I just wanted you to kind of bring back all this information about functions and scatter plots to help you. And right away, just in general, this first one you can see it looks like a quadratic on the left here. So that would be a quadratic function. And this one on the right, this scatter plot would represent a linear function. And we're going to do a couple problems just to help us remember how to do using the stat plot on our graphing calculator. And this first problem is an example showing how the population and the number of represented in Congress relate for each other. And you've probably been familiar with this, that the population would be the independent variable, and based on the population of our states, it's determined the number of representatives. So whenever you're looking at data and you're going to be determining an equation for it, you first have to figure out what's the independent data and what's the dependent data. And in this example, our population is the independent, so that would be our x value, and our representatives would be the dependent. It matters how big the population is, determines the number of representatives in that state. That's how our great country was established, for thinking of our House of Representatives. So when you're using this in our graphing calculator, the first thing you're realizing is you're going to be putting this into your stats, and your L1 will be your x value and your L2 will be your y value. So go ahead and bring up your calculator and let's plug these in. Okay, so the first thing to realize is if you have data in here already, then you need to clear it out. And the way I got to the screen, remember, is if you hit Stat and Edit, and then we're going to clear out any data that might be in here. So L1, we go up and we clear, and we hit Enter. So once your data is cleared out, you'll put our population into L1 because it's the X, and then our representative data into the L2 for Y. So go ahead and do that. Okay, so when you do that, you also want to make sure you clear out any data in your Y equals, so anything you're graphing. So once you have your both lists in, now we're going to turn on the stat plot to graph it so we can see what kind of function we have. And if we hit second Y equals and turn on our stat plot by hitting Enter on, then we want to go to zoom number 9 for zoom stat to see what the graph looks like. And clearly we can see we have a linear graph, which makes sense that it would be a relationship with linear with how our founding fathers set up our democracy. So to see what equation it is, we know it's a linear the way this data is. So we're going to now find the equation for the data. We hit stat again, and this time we're going to calculate, and we're going to go to linear regression, number 4. Okay, so now this equation, our A is our slope, and our B is our y-intercept, and we're going to use 3 significant digits. So we're going to go ahead and write that down here. So this is our equation, y equals 1.73x plus 0.392. And we can use our equation to make a prediction. If another state, such as Oregon, has a population of 2.8 million, that will be plugging in 2.8 in for the x to find the y value. So y equals 1.73 times 2.8 plus 0.392, and that would be equal to 5.236, which means, because we're talking about people, number of representatives, that means that Oregon would have 5 representatives. Okay, let's try one more. Okay, so in this problem, we have data that was gathered from a study that compared the speed and the average fuel economy in miles per gallon for cars. So go ahead and use this data to come up with an equation. We're not going to worry about number 5 tonight. I just want you to take a look and figure out what kind of function this is and come up with number 4 here, find a regression equation, and then bring it back. Okay, so when you plotted, put in your data for L1, you should put the speed in for L1. That's independent. It matters how fast you're going. Will depend, your fuel economy will depend on how fast you're going. So the X is your speed, and your fuel economy is your Y for L2. Then once you put the data in, you should graph it. And if you take a look at this scatter plot, you could make a case that this is quadratic or that it is quartic. But you could not make a case that it's linear or cubic. So if you thought it was quadratic, you would hit stat over to calculate and then quadratic, and that would give you your equation. You plug in this for A, this for B, and this for C, and remember that the r squared is telling you how accurate that equation will make a prediction. The closest this number is to 1, the better your equation fits. So if you ran the quartic as well, that would be number 7. And they have your equation, and then you have to scroll down to see your r squared. Your quartic does have a higher r squared, so you could make a case for quartic as well. It's another quadratic, though. You could say that this is an outlier, and so either one, because especially since the r squared are so close, you could make a case for either one. It's also simpler to use the quadratic equation, so I went ahead and used the quadratic equation. So that equation is y equals negative 0.008x squared plus 0.746x plus 13.47. And again, the key here is just to understand what kind of function and how to find your equation of best fit. So hopefully that reviewed the information for you. And if you have any questions, please come see us. Have a great night.